Please everyone welcome Ananya to the stage.
Hi everyone, my name's Ananya and my project is about coral restoration. Now, what are corals? Corals are amazing. They're made by tiny animals called polyps that settle together and form a shell-like skeleton that we know as coral reefs. Why are corals important? Well, I could list a lot of reasons why corals are important. The main one is that they provide over half of the world's oxygen. Sadly, these precious reefs are dying at an alarming rate, which is something I want to change. My appreciation for corals started when I began diving. I love diving. I've done over 70 dives and I've been working on a coral restoration project some way or another since I was 12. Last year, in my previous school, I designed and executed my own coral restoration project. Since joining TIF, I've been focusing on 2 project streams to build on my past experiences. For my first project stream, I wanted to gain more expertise and connect with professionals in the field of marine biology and coral restoration. Because while all the previous projects I've done were great, I didn't really know what I was doing or how it exactly impacted reefs. For my second project stream, I wanted to continue building on my own coral restoration project because I felt I could improve on my previous efforts. For stream 1, the first thing I did was compile a portfolio on LinkedIn, which lists all my past projects and experiences. This was to gain credibility. Next, we forwarded my LinkedIn to a bunch of organizations and professionals that I was interested in learning from. We reached out to many different organizations, and 2 of them were open to scheduling a call and discussing different possibilities. The first call was with the co-founder and CEO of Regenerative, Rico Yu. Regenerative is an innovative organization that's doing a lot of interesting work in the field of coral restoration. And while they did not have the capacity to offer an internship, she was able to give me a lot of valuable advice and has continued to mentor me. The second call was with Professor James Reimer, who owns the MISC lab in UQ University, and he was really positive about a possible remote internship. After a lot of discussions and emails, I got the opportunity to go down to Okinawa in person and learn more about what they're doing. The visit to Okinawa was a great experience because everyone was so nice and I got to learn about their projects and how I could potentially help with them. After talking to everyone, it seemed the best way I could help in a meaningful way was by analyzing images of different reef sites for Dr. Fabian Gozer. Dr. Gozer is working on a research study that requires images of coral reefs to be analyzed, and that's the work I'm supporting him with. This is an example photo of the type of image I'm analyzing. There are 100 images like this, and on each image there are 50 random points. Under each point, I zoom in and identify the genera of coral that's there. There are roughly 85 coral genera in Japanese waters. This is a lot of genera to remember. So to help me memorize each genera, I made a deck of flashcards. Each flashcard has a description that helps me memorize the genera. This technique is proving to be effective and I'm going to the images a lot faster. I've memorized roughly about 18% of the genera that are in this flashcard deck. I'm very grateful for the opportunity to learn from Dr. Gozer and to be able to contribute meaningfully. For the future, I hope I'm able to maintain that connection and continue to learn from him. Moving on to my second project stream. I'm incredibly passionate about coral restoration, specifically designing artificial reef structures. What are artificial reef structures? Artificial reef structures are underwater structures that mimic natural reefs to attract corals to attach onto them and provide the corals a substrate to grow on. In my previous project, I designed and deployed my own artificial reef structures, and after a full year, I'm very happy to say, you can see corals beginning to form and colonies clustering. While this was a good first prototype, I decided I wanted to level up my design and model the optimal reef structure to promote coral biodiversity. This is a big statement. What does the optimal reef structure look like? Artificial reef structures can be designed to have many different purposes. Now, I was very clear I wanted my structure to boost coral biodiversity. That's where I decided to start and research the specific features in reefs that encourage coral biodiversity. After doing a lot of case studies and research on what the optimal features and materials are, I decided to make a database with all the information I had gathered to provide me with more clarity. I first added all of the features I wanted to include and an example of what they looked like on existing structures. Then I made a list of all the different materials that I could use and added key factors to consider when picking materials. Based on those factors, I assigned each material a weighted score to help me pick what the optimal material would be. I decided on natural rock. I went through a similar process in deciding where the optimal location to deploy my structure would be, and I decided on North Bali. After making that spreadsheet, I was able to send it to my mentor Rico and get her feedback on the list of features and how practical they are. With all of the data and information I now had, I felt like I had a rough idea on what I wanted the optimal reef structure to look like, and I felt confident enough to start modeling it. I'd like to share my design with you all. There are 5 key features that I wanted to include in my design. The first feature I wanted to include is biomimicry, which means mimicking elements from natural ecosystems and incorporating those features in the design in order to better integrate the structure with its surrounding environment. This is why I chose to model my design of mushroom corals, because there are coral genera that are commonly found and are great for settlement because of their curved shape and texture. The second key feature was having a textured surface to make it easy for corals to attach and settle on my structure. That's why, once more, the top layer of my design is modeled of mushroom corals, as they have a lot of grooves and textures. The next key feature is structural complexity, which is important for mimicking a natural reef's different curves and dents. This is why my design has 2 layers to create various heights and sizes. The next important feature is spatial variety, which is a mix of different spacing areas that influence water flow in a natural reef. This is why I placed the mushroom coral toppers in a bit of a scattered manner to influence the water flow and nutrient delivery. And the last feature is including a sturdy base in the design to make sure that it doesn't get knocked over in a strong current. This is why the core of my design is a geodesic dome, because it's wide and sturdy but still provides all of the angles necessary. Now that I have my design, my next steps are figuring out and planning out the details on how to produce and deploy my structure. Thank you for listening.